All right, let's talk about the digital brains that power pretty much everything in our world. Whenever you're building an electronic device, you hit this really important fork in the road. Do you need a powerful, do-it-all kind of brain? Or do you need a small, super efficient, specialized one? That right there, that's the core difference between a microprocessor and a microcontroller. And getting that distinction is key. I mean, just think about it for a second. Your laptop, it can browse the web, edit 4K video, run a dozen different programs at once. Your microwave, its job is to, well, heat up your leftovers for a minute and a half. They both have a brain, but they are totally different tools for totally different jobs. And understanding why is how we start to understand all the tech around us.
So first up, let's meet the brain you're probably most familiar with, even if you don't call it by its proper name, the microprocessor, or MPU for short. This is the powerhouse. This is the generalist that can handle just about any task you can possibly throw at it.
So what is it really? Well, at its very core, a microprocessor is the central processing unit, the CPU, of a computer, all squeezed onto one tiny little chip. Just think of it as pure, raw intellect. Its whole job is to fetch instructions, figure out what they mean, and then execute those commands. It does all the heavy lifting, all the thinking.
So when you see a chip like this, you're looking at just the processor. It's incredibly powerful for sure, but it can't do a single thing on its own. It's kind of like the star quarterback of a football team, amazing at what it does, but it absolutely needs a whole team of supporting components around it to actually play the game.
And this is what that support system looks like. To build a working computer, the MPU has to connect to all these external parts. Things like memory chips, your RAM, and all the input/output ports for your keyboard, your mouse, your display. The MPU is the heart, definitely, but it's just one part of a much bigger, more complex body.
And really, it all comes down to this. MPUs are built for two things: raw performance and flexibility. We're talking seriously high clock speeds, measured in gigahertz, that give them the power to run these huge, complex operating systems like Windows or Android. But, all that power comes at a price. They get hot, and they consume a lot more energy.
Okay, now here's the secret sauce. This is what gives microprocessors their real superpower. It's a little piece of hardware called the Memory Management Unit, or MMU. The simplest way to think about it is as a traffic cop for memory. It lets all your different programs think they have the computer's entire memory all to themselves, while the MMU is working behind the scenes, directing traffic and figuring out where everything actually goes in the physical RAM.
And that is the big deal. The presence of an MMU is maybe the single biggest thing that separates a microprocessor from its cousin. This one piece of hardware is what makes it possible to run a big, multitasking operating system like Linux or Windows safely and efficiently. Plain and simple, without an MMU, you just can't do it.
So, now let's flip the coin and meet the other player in this game. If the MPU is our powerful generalist, then the microcontroller, or MCU, is the efficient, laser-focused specialist. It's designed to do one job, and do that one job perfectly.
The magic word here is integrating. A microcontroller isn't just a CPU on a chip. No, it's basically an entire computer system on a single chip. It's got the processor, it's got the memory, it's got the input and output controls. Everything is baked right into one tiny, self-sufficient package.
So when you look at a development board like this one, that small black square right in the middle, that's the microcontroller. And unlike that microprocessor we saw earlier, that one little chip has everything it needs to get to work. It's a complete, if simple, little computer.
And here, you can really see that difference in architecture laid out. Remember how the MPU needed a whole team of external parts? Well, the MCU has its processor, its memory, and all its I/O living together on one piece of silicon. This makes the whole design way simpler, more compact, and a whole lot cheaper to make.
So an MCU's strengths are really the mirror image of an MPU's. It's not about speed and power. It's all about efficiency and reliability for one specific, often repetitive task. Think about the controller in your washing machine. Its job is simple, it's defined, and it never, ever changes. And that focus allows for incredibly low power consumption, which is why MCUs are perfect for battery-powered stuff like sensors and wearables.
All right, so we've met our two contenders, the generalist and the specialist. Now let's put them right next to each other and see how they stack up.
So, on one side, we've got the powerful generalist, ready for absolutely anything you can imagine. And on the other, the super efficient specialist, designed and perfected for its one true purpose.
This table really lays out all the trade-offs, doesn't it?
The MPU is the heart of a computer system, while the MCU is the heart of an embedded system. That all-in-one design of the MCU makes it way cheaper and lets it just sip power, but its speed is measured in megahertz. The MPU needs all those expensive external parts and guzzles power, but in return, you get that blazing fast gigahertz performance. And that performance gap dictates the software. MPUs run full operating systems. MCUs, they run much simpler code, either something called a real-time operating system for super precise timing or code that runs right on the hardware itself, what we call bare metal.
So here it is, the big question for any engineer or designer. How in the world do you choose? Do you go with an MPU or an MCU? Well, the answer is actually surprisingly simple, and it's probably not what you think.
And this right here is the most important thing you can take away from all this. The choice between an MPU and an MCU, it doesn't start with the hardware. Not at all. It starts with the software. The very first question you have to ask is, what does my device need to do? And your answer to that question will point you to exactly which brain you need.
Let's just make this crystal clear. If your product needs a fancy graphical touchscreen, if it needs to connect to the internet, if it needs to run multiple apps at once, basically if it needs a full-blown operating system like Linux, then you need a microprocessor, period. But if your product needs to precisely control a motor or read a sensor value every single millisecond with perfect timing and run for a year on a tiny battery, then you absolutely need a microcontroller.
Now, of course, in the real world, things can get a little more complex. A lot of modern devices, think smart appliances or industrial controllers, they actually use both. You might have a powerful MPU running the beautiful touchscreen display and handling the cloud connection, while a tiny little MCU is in the background, handling all the critical real-time stuff like safety checks and motor control. It's a hybrid approach that really gives you the best of both worlds.
So, let's wrap it up. It's pretty simple when you boil it down. The MPU is the powerful brain for devices that act like computers. The MCU is the efficient brain for electronics that have one dedicated job. And the most important rule of all, always let your software needs decide which hardware you choose.
From our cars to our coffee makers, these little digital brains are absolutely everywhere. So, the next time you have an idea for some new gadget, you'll know exactly where to start asking the right questions. Does it need the raw power of a generalist or the laser focus of a specialist? Which brain is going to power your next big idea?